Hi everyone, welcome to Scalar's YouTube channel. I'm Sejal Chugh, SD2 at Microsoft, and today's video is on the introduction to the OpenAI Developers Platform. But before we get started, go check out Scalar's masterclass by industry-leading experts on Scalar's event page. The link is in the description below. Now let's begin. Today we're going to talk about something that has become pretty famous and interesting, which is the GPT models. For those of you who are unaware, GPT stands for Generative Pre-trained Transformers. OpenAI has come up with an OpenAI developer platform which provides a set of tools and resources to enable these users to build the applications and leverage their cutting-edge AI technology. They have come up with a couple of use cases that can be leveraged to build apps by supplying your own testing and training data. In today's tutorial, I will help you quick start these APIs by making your first API call. We'll go over a use case to leverage this API, the authentication mechanism, basic concepts, and build our first project using the OpenAI developer platform. I would also walk through the structure of the training dataset and installation guide for Python and the OpenAI Python library. Let's head over to the OpenAI developer platform. First, we need to create an OpenAI account or sign in using our Google or Microsoft account. Next, we need to create the API key. For this, we navigate to the API key and create a new secret key. Make sure to save this key somewhere safe and not share it with anyone. For the purpose of this tutorial, I'll be using a sample key. Now, Python provides an OpenAI AI library which makes working with these APIs very simple and efficient. So I'll be using Python to code the backend development. You can head over to the Python's page and download the Python 3.12. For this, we need to install the OpenAI library. For that, you can go over to the API reference and check out what reference we are using for the demo. So for this, I'll be using the Create Completion API, which is the version 1 legacy API of OpenAI. Now, after you have set up everything, we will head over to the demo. For simplicity, I'm using Google Colab to show the end-to-end demo of the use case. I'm using the smart home control system where we will have a couple of inputs and then outputs that finally are generated by the OpenAI developers platform. Let's head over to the walkthrough of the use case. For the purpose of this demo, I'll be using a smart home control system use case to utilize the OpenAI APIs and demonstrate how we can get the required output. We can leverage the natural language processing capabilities of the GPT models for a smart home control system to interpret the user commands for these various devices in a smart home environment. Step 1 would be to define the tasks. We want to build a smart home control system that allows the user to control various devices in their home using natural language commands. Next, we would need to choose the model. Now here we select a pre-trained GPT model that is suitable for the understanding and generating the text-based commands. For example, we choose the DaVinci 2 due to its strong understanding capabilities. Next step is prompt designing. Prompt designing involves designing prompts that effectively communicate the user's intent to the model. We craft prompts that include information about the action that the user wants to undertake. For instance, a user can undertake, say, turn off the lights in the bedroom, or switch on the AC, or turn the thermostat to 37 degrees, or lock the front door. These are just some examples that a user might want to undertake in his smart home system. Next is data preparation. We further gather data on these smart home devices and their capabilities using a common use case. This data helps us formulate and evaluate the model's responses. Step 5. Prompt refinement. We experiment with different prompts, iterate based on the model's responses, adjust the wording, add context, improve the accuracy and reliability of the GPT model. Next step is models fine-tuning. This is an optional step. Depending on the performance of the base model, may or may not to adjust the fine-tuned parameters of the GPT model. For this, we need to enhance the understanding of the domain and improve the accuracy of the model. Next step is the evaluation. We evaluate the accuracy and usability of the generated commands using metrics such as success rate, accuracy, user feedback, or error analysis. This helps assess the effectiveness of our prompt engineering and fine-tuning efforts. Finally, once we are satisfied with the smart home control system, we deploy it in the real world and check for user feedback. Users can input their natural language commands and the system will interpret them and finally generate an output. We continuously monitor the system's performance and user interactions to identify areas of improvement. We may involve refining the prompts, updating the model, or integrating new devices and increasing the functionality to enhance our model's development. In today's use case, I will illustrate how text-to-command functionality of the OpenAI developers platform powered by these GPT models can enable intuitive and simple natural language interactions with these smart home devices, simplifying the user experience and enhancing home automation capabilities. Let's see how to structure this dataset. Now, to structure the dataset, we would need a command spoken in natural language, and then that command gets finally translated into an action and a device. So let's say the command will be can cover a variety of things. For instance, turning on the bedroom lights. So here the action becomes turning it on and the device becomes the bedroom lights. So the action column would specify each command like turn on, turn off, set, increase, decrease, lock, unlock. Make sure to include a wide variety of actions so that to enhance your use case. The device column would indicate the targeted command. For instance, lights, the AC, thermostat, security camera, some speaker. We can include a wide variety of devices that are commonly available in any smart home system. Here is an example of a sample dataset that I will be using for the purpose of this demo. I've set a couple of commands here, for instance, turning on the living room lights. These gets translated to turn on the action and device as the lights. For instance, unlock the garage door. So unlock becomes your action and the device becomes the garage door. Or dim the bedroom lights. So decrease becomes the command and lights becomes the devices. We can also have something related to a smart speaker, which is very commonly available in smart homes these days, like increase the volume or decrease them. Now let's head over to the demo. For the purpose of this demo, I'm using the dataset that was shown in the PPT. I've updated it in an Excel sheet and uploaded it on the Google Colab sample data. For this we will be using now in the code. Now we need to import a few libraries. To read this dataset, which is in the CSV format, we need pandas. And to send requests to another API, we need the requests. Let's run this field. Yeah. Now we need to read this dataset. So to read this dataset, let's assume that we are reading it using the pandas library and using the function called read CSV. Now here, we need to give the name and the path of the file. So we'd copy the path. Yeah. And just to show, for the purpose of this demo, I will show the data that is being run. Yeah. So as you can see, this data is now loaded into our system. Next, we move on to create our training dataset. To create the training dataset, we will read this data one by one and add it in the string format to our training data. For instance, I consider training data as a string initially, then loop over this dataset. One by one, create the string that I want. So let's assume that I'm taking something like input, then having the command here, and then having output, and having the action with the comma separated, and then device. So this is the format that I want to create my dataset in. So for this, I will be using a sample data, and then starting saying, okay, I want input. Next, I want to add the command text of this. So since the column heading is command text, I use command text, and index. And with this, since I'm doing it in the next line, so I add a /n for the next line iteration, and now the output. And the output, the column name is parameters. So I say df parameters and index. Now this becomes the string that I want for each iteration. After that, I want to add a /n for multiple iterations as well. So I add an ending /n. Next, I need to add this in the training data that I had initially. So whatever was initially added, and add this D as well. Now let's output the training data. Let's run this. Command text has a space in between at the top, so we'll have to put that, and let's say parameters /n output. Perfect. Yeah, so as you can see, this input is now our input to the GPT model for the training data set. Now let's say I want to put a line in between as well, so I will add a double N here. So now my input and output is divided for the different use cases that I want to take in the training data set. Now let's create the testing data set. Let's say I want to add my input as turn off the bedroom speaker. Let's say that is my input. Now input to model would be my training data plus my testing data. This will be my input to the model. And let's say I want to print it. So as you can see, at the end, my input has been attached, which is turn off the bedroom speaker. This may not be required. Yeah. Perfect. So now I have the input here. I have all these use cases, which are the training data, and the final testing output, which I need the action and device for. This will be generated by the GPT model. Now let's go ahead and make our first API call. The URL for that API call which we need, we can get from the OpenAI platform. So if you see here, I have the API reference. I'm using the completion API, which is the OpenAPI version 1 completion. Let's copy this, paste the URL here. Next, we need to create the model that we would pass to this particular response. So our model, now these parameters as well, I'm getting from the API reference. Like what all do we need here? We need to pass the model, the prompts, the maximum number of tokens, the temperature, the authorization. This is the bearer token or the API key that we had initially copied, and the content type, which is application.json. So we'd fill all of this information and then go ahead and give our first call request. So let's first create the model parameters. So since we are using the DaVinci model, I've put that here. Next, we are going ahead with the prompt. So prompt, we need to convert the text to the programmatic, or let's say convert the command text to the parameters, right? Since we need to convert these to the parameters. And next we would just simply append our input data model to here, the prompt. Finally, we create the payload. For the payload, we need to convert this into a JSON format. So we'd use JSON dumps X and then add the headers. Now for headers, we need two kinds of headers. As you can see here, I have the content type, which is application/JSON, and the authorization or the bearer token. These are the two headers that we would require. So adding them, first one is the authorization. This needs a bearer token. And here I will put the API key. Now API key, I'm using a sample one. You can use the API key that you would be provided when you log in to the OpenAI developers platform. After putting the authorization, I will be having the content type. Here we have application/JSON as the content, since I'm converting it into JSON and then sending it to the API. Finally, we make our post call. So if you see here, it's a post API. So I'll be making a post call to this. Let's say the response of this API, I'm using the request library, which is provided by Python, using the post call, passing the URL. The data is my payload, and then headers are the headers that I have created right now. And let's say at the end, I just want to print the response. Now for this, if you see what I've done right now is I've created the URL, created the model that I want to use, created the prompts or the parameters that I want to send to the model. Finally, with my authorization, with the bearer token and the API and the content type, I'm sending a post request. One thing to note here is that I'm using the JSON library here to create it into a JSON format. So I would need to import that as well. So let's go ahead and import the JSON library. Yeah. And now we can run this. So as you can see, I got a 200 response. Now to print this response, I need to check out the response format. So if you see here, my response format is this. Yeah, so since my response format is this, if you see here, this is the text output where I have received it. So here I need to say response and then check the text in that response and find the choices in it. So to print this response, we would say response.text. And let's run it further. Yeah, so now our response is similar to the one that we are seeing here on the API completion. So here if you see, the testing data that I had added was turn off the bedroom speaker. Now the ideal solution that we would have achieved was action being detected as turn off and the device being detected as the bedroom speaker. So that is what we've observed here. The output is the action detected as turn off and the device being detected as the speaker. So if you see, ChatGPT, based on the prompts that it had seen in the training data, took your input of the testing data and generated an output based on that. You can model it further, enhance the prompts, get the final output, call the completion API to get the required responses. I hope I was clear on how to model the smart home control system. In this, I leveraged the natural language capabilities of the GPT model to use the training data and the testing data to get the required output. In this, I interpreted the user's commands to control various smart home devices and get the action and the device that are associated to those commands. For this, the first step was to define the task that we need. Second would be to find the model, the appropriate model that is required from the GPT's list. There are a lot of lists based on different use cases. Another one is to use images to get the responses. One can be to understand the code. Another is to understand the natural language. Another is to understand the text that is present. Another is to summarize it. Another is to generate speech from it. These are just to name a few. Next is prompt designing. Prompt designing is a very crucial part in this step because you are designing the training data set of the model. Here, you need to supply the input and the output based on how you want to view the testing data. Next is the data preparation. For this, we are using two columns, which is the input, which is the command, the natural language command, and the output, which has two things, the action and the device. The action that you want the user to take, the action that you want the device to take. Next is prompt refinement. Based on how we see the model performing, we are adjusting the wording, we are adding context, we're including constraints, fine tuning the model. All of this is in the step 5 and 6. Finally, we move on to the evaluation part on how our model is performing. This we check based on the accuracy, the user feedback, the metrics that are there on the platform, as well as some open source metrics. Finally, we deploy it in the real world. Coming to another use case, which is to see that, okay, we need to convert the text to an API signature. Now, this is also another use case that most developers use. Now, for this, we are using the simple natural language programs to convert the API signatures of the particular platform. Now, here, what I'm using, I'm creating a reminders or a grocery list. You can have other things as well, but let's say you have an API that adds things to the grocery lists, deletes things from there, fetches the grocery list, sets reminders for you. So in that, there are a set of APIs that would already exist, the set of get and post APIs. So now here I'm using natural language to convert the textual commands that the user might say to those API calls, specific API calls. So let's see here. What do I have to buy from the grocery store? Now, whenever a user asks something like this, it basically needs to read the grocery list or to understand that, okay, what I might have added in the past. So for this, I'm converting it to the method get, and the component becomes grocery list. Now let's say I'm saying show me my reminders. So now here the user show me is the action or the method, which is get, and reminders is the component that the API signature wants to call. So the API signature becomes method get and the component as reminders. For instance, if I have add tomatoes to the list of groceries. So now add becomes the method signature, which is post or put, and tomatoes becomes the data that I want to put in. So I have data as tomatoes and component becomes the list of groceries or the grocery list. ChatGPT is very clever to identify these items from the natural language text and allocate its specific place. So add goes to method put, the component becomes grocery list, and the data becomes tomatoes. So later on, let's say if the user says put onions in my grocery list or remind me to get some onions, he'll automatically put the method as put, the component as reminders, and data as onions. Or remind me to get some post-it notes. So it's automatically detecting that, okay, data is post-it notes, the component is reminders, and the method is put. So on, when we supply this command and the output signature to the ChatGPT model and use any other testing data to get the response, our GPT model successfully is able to identify the three components and give it to the result. In conclusion, the text-to-command feature of the OpenAPI Developers Platform presents a groundbreaking advancement in natural language by allowing users to convert simple, plain text commands into actionable responses that can be understood by API signatures or different API platforms. So that's all for today's video. I hope you enjoyed it. Do like the video, share it with your friends, and subscribe to Scalar's YouTube channel for more such content.